We want to determine if the given infinite series converges or diverges. So to help us decide on the most appropriate test, notice that a sub n contains an exponential 3 raised to the power of n, which in most cases when we have an exponential, we want to use the ratio test. But also notice how this does resemble the geometric series 1 divided by 3 to the n, which we know converges by the geometric series test, where the absolute value of r would be equal to 1/3. So the tests that we should consider are the ratio tests as well as the direct or limit comparison test. And for this example, because we have an exponential, let's go ahead and use the ratio test. So let's review the ratio test before we apply it. The ratio test states that if the sum of a sub n has positive terms and the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n equals L, if L is less than 1, then the sum of a sub n converges. If L is greater than 1, then the sum of a sub n diverges. And if L equals 1, the ratio test fails. So going back to our example, notice that the given series is the sum of a sub n. Then to find a sub n plus 1, we would substitute n plus 1 for n, which would give us 5 times the quantity n plus 1 divided by n plus 1 times 3 to the power of n plus 1. So now let's find our limit. We'll have the limit as n approaches infinity of a sub n plus 1, which would be this fraction here. Notice if we distribute, we would have 5n plus 5 plus 1. So I'm going to write this as 5n plus 6 divided by the quantity n plus 1 times 3 to the power of n plus 1, and divided by a sub n, which is 5n plus 1 divided by n times 3 to the power of n. So we have the limit of this complex fraction, or a division of two fractions where we have the top fraction divided by the bottom fraction. Instead of dividing by the fraction on the bottom, we'll now multiply by the reciprocal of the fraction on the bottom. So this limit is equal to the limit as n approaches infinity of the top fraction times the reciprocal of the bottom fraction, which would be n times 3 to the power of n divided by 5n plus 1. Now this is going to simplify, but if we look at 3 to the n power and 3 to the power of n plus 1, 3 to the power of n plus 1 has one more factor of 3 than 3 to the n. So this simplifies to 1, and this simplifies to 1 factor of 3. So now we have the limit as n approaches infinity of, in the numerator we would have n times 5n plus 6, and the denominator would be, well, 3 times n plus 1 is 3n plus 3, so we'd have 3n plus 3 times 5n plus 1. Let's go ahead and multiply this out. This is equal to the limit as n approaches infinity. The numerator would be 5n squared plus 6n, and the denominator would be 3n times 5n, that's 15n squared. And then we have 3n times 1, that's 3n, plus 3 times 5n, that's 15n. 3n plus 15n is 18n. And then 3 times 1 is 3. Notice the degree of the numerator and denominator are the same, and therefore this limit is equal to the ratio of the leading coefficients, which would be 5/15 or 1/3. Which is good news because this is less than 1, and therefore by the ratio test, the given series converges. So therefore, by the ratio test, since the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n is equal to 1/3, which is less than 1, the series that we were given converges. Now I think I forgot to mention that when I set this up, I did not include the absolute value as stated by the ratio test because notice that if n starts at 1, a sub n and a sub n plus 1 are always positive. Okay, I hope you found this helpful.